between the age and weight and heart rate. The researcher wishes to determine the relationship between the heart rate and weight while controlling the age. Clear? Find the partial correlation among the heart rate and weight while age is controlled. Set up the hypothesis. Test the hypothesis 5% level of significance. Interpret your result. Brother here. Rate and age. Three variables here. Weight, heart rate and age. All decimal point is given 0. This is scale. Clear? We need to calculate the partial correlation between weight and heart rate while controlling age. Click, analyze, correlate, partial. Clear? Now weight and heart rate transfer in variable window, age controlling option, select the mean and zero order correlation. Continue for two-tailed test, check out, click OK. Now brother we get this table. Okay, clear? I already this table copy and paste here. And give the two shade. About table is green and this is pink. Now the result of the partial correlation highlighted by the pink color here. Okay, the rectangle shows there was a mild negative partial correlation between the dependent variable heart rate and independent variable weight while controlling for age, which was not statistically significant. Why? This pay value is given 0.492. Clear? There is no relationship. There is no statistical relationship between the weight, heart rate and weight while controlling the age. Now here, however, when we refer to the Pearson correlation product moment, also known as zero order correlation between the heart rate and weight without controlling for age, highlighted by the blue rectangle, we can see there is no statistically not significant mild negative correlation between the heart and weight. So brother, here partial correlation we find out. In the blue line we find out the Pearson correlation coefficient between the weight and heart rate without controlling the age. Clear? Now what is the value here? Minus 0.264. What is the value here? Partial correlation minus 0.264. Here what has been except age node, not statistically significant. What has been here? Except age node, not statistically significant. Clear or not clear? Next is multiple correlation coefficient. Clear? Here systolic blood pressure is dependent variables, age and BMI are the independent variables. Clear? Whether we take this data from here. your multiple correlation coefficient. Clear? Brother, here is BP, age, BMI. We enter this, I take the new file. First variable is BP, systolic blood pressure. Second variable is age. Third variable is BMI. All decimal point 0. Clear? Brother, here is dependent variable. Click analyze, regression, linear. Clear? Now SBP dependent variable. This is the independent variable. This 95% already is given. Continue, click OK. Brother, what is the value of R here? 0.975. What is the value of R square? 0.951. Check your answer. What is the value of R? 0.975. What is the value of the R square? 0.951. Clear? Clear or not clear? Now here, all steps I write here and explain. There is no linear relationship between the set of the predictor, it means independent variable and dependent variable SBP. Now multiple correlation R 0.97, R square 0.951. This means about 95.1% of the variation in SBP explained by the age and BP together. Clear? F, come to the second table. F is equal to 68.638. P value how much? 0.001. Brother, come to here. What is the value of the F? Is here. Clear? Now we write here F value. We write our P value, level of significance. Right, computed P value is less than the level of significance, so we reject the null hypothesis H. Note it is significant. We may conclude there is a statistical significant relationship between systolic blood pressure and the combined predictor age and BMI. The model explains 95.1% of the variation in SBP indicate a very strong predictive relationship. Both age and BMI contribute positively to SBP. Clear? So the same thing here, we compare between the test statistic value of F and critical value of F. Clear? Here this value more than this critical value, reject the null hypothesis A. Here P value less than alpha, reject the null hypothesis value. So brother, by the both method your result is set. Now this chapter is finished. If you want to ask any question, you can ask.